What if the center of our galaxy isn't a supermassive black hole after all, but instead, a massive amount of dark matter? That would flip our long-held understanding of the Milky Way, but in a new study, scientists from Italy, Argentina, and Colombia say the evidence stacks up. The idea of a supermassive black hole at the center of the Milky Way is well established, based partly on the orbit of specific stars like S02. Scientists study these objects in orbit as a way to extrapolate what they're actually orbiting around, in this case, a supermassive black hole 4 million times the mass of the Sun. That supermassive black hole is called Sagittarius A. S02 and other established stars are pulled every which way in their orbits around Sagittarius A, into extreme orbits that scientists measure in order to get some idea of what the supermassive black hole is all about. Think about how soap suds behave as water swirls down your drain and what that tells you about what the drain is doing. Even if you couldn't see the drain directly, the behaviors around it would give you clues. Scientists are still conducting that kind of research, but a new-to-us class of space objects is casting a shadow over the black hole theory. Physicist Andrea Ghez had told Science Alert in 2020 that these objects look like gas but behave like stars. There are 6 G objects of this kind, with orbits ranging from as 170 to 1,600 years long. Recently, their wonky orbits have led to a new, competing theory to describe the center of the Milky Way. In 2014, scientists observed object G2 pass its closest point to Sagittarius A and become stretched out and distorted, a phenomenon known as drag. This, scientists from the International Center for Relativistic Astrophysics in Italy say, is a sign that Sagittarius A might be something other than a supermassive black hole. In 2020, the same research team published findings that G2 and S2 might be experiencing the same different kind of gravitational pull near Sagittarius A. They say the way those objects behave is more consistent with the specific kind of dark matter. In their side-by-side analysis of black hole versus dark matter is the explanation. Dark matter was a better statistical fit. Dark matter is matter that we can't see, but we can measure it through its effect on gravity and objects around it. Dark matter makes up 30% of the mass of our universe, yet it's invisible and, so far, not directly observed. But its presence, along with the related idea of dark energy, makes up a total of 99.5% of the mass of the universe around us and provides the missing piece to a ton of questions in physics and cosmology. Dark matter can and does turn into black holes, but the scientists posit that Sagittarius A is instead a blob-like mass that will require a lot more material in order to turn into a black hole. For now, it could just be a dense blob that still attracts nearby objects as a black hole does. And if it is a kind of proto-future black hole, that could explain how supermassive black holes form in the first place, something scientists have been puzzled by for decades. In this new study, accepted for publication by newsletters, the Italian, Argentinian, and Colombian scientists explained that not just the directly affected G2 and S2 space objects line up with the dark matter theory. They've expanded their study to the closest, most well-understood stars orbiting Sagittarius A and found those stars also behave consistently with the dark matter model. So, what do these findings mean? Well, when it comes to the swirling mysteries at the heart of the galaxy, all news is good news. These scientists have put out an ambitious new theory, and subsequent work will either back them up or respectfully disagree, citing different analysis and observation. That will continue to lead toward a better understanding of supermassive black holes and of Sagittarius A in particular, and could help to solve the mystery.